All right, guys. So good evening and welcome back to the second lecture of C programming. Now, I want you all to open your notebook and give the heading 1.3 program or software. So come on, open your notebook and give the heading 1.3 program or software. Come on, do that. And under that, you can just write refer PN, refer PN, refer PN5, refer PN5. Sorry. Okay. So now let's understand what we did yesterday and what we are about to do today. So yesterday we studied what is a computer, what is computer memory, and I hope you remember we studied three generations, three categories of programming languages, and these three categories were machine language, assembly language, high level language. All right. Now today we'll start with a topic called program or software. Now you already know what is a program, so let's write the definition of a software. Okay, so now what exactly a software is? So I'll dictate the definition and I want you all to write this definition in your notebook. So come on, write the definition. A software is simply a set of programs. I repeat, a software is simply a set of programs. All right, guys. So now, before I explain you this definition, let's understand examples of some software. Now, what happens is every app on your cell phone, I repeat, every app on your cell phone, be it Facebook, be it Instagram, be it Snapchat or anything, okay? Every app on your cell phone is basically a software. Microsoft Word is a software. Google Chrome is a software. So anything which you use on the computer is a software. Okay. So first of all, write some examples and then we'll discuss further. You can write examples: Instagram, Facebook, Google Chrome, Microsoft Word. Okay, now how do you define a software? What exactly is the meaning of the word software? So listen, now what happens is you already know what is a program. All right, now a software is nothing but a set of programs. So whenever the program is very big, or I will say whenever some application is very large, inside that application there will be many small programs, and these programs collectively will be called one software. So for example, the WhatsApp on your cell phone is a software inside which there will be small programs. Okay, Microsoft Word is basically a software inside which there will be many small programs. So whenever you have a collection of programs doing one particular work, okay, then that collection of programs is called a software. And please understand that every software will do one particular work. For example, Google Chrome will do the work of web browsing. Microsoft Word will do the work of documentation and so on. Now, one more thing I want to tell you over here, that many a times, the word program and the word software are used interchangeably. That means sometimes we'll call a software as a program or a program as a software, which is okay, which is not wrong. But just understand this way, that whenever there is a group of programs, okay, into one unit, then that group is called a software. Okay. All right. Now we'll discuss some softwares which are important to us in this CP language. I mean, in this CP subject. And one such software, which I told you yesterday, is a compiler. Very important. Now, if CP lectures have started in your college, then you must have come across these terms: compiler, compilation, compiling, and so on. Now, I'm sorry. Now, what exactly a compiler is? So first of all, give this heading compiler and I'll dictate its definition. By the way, its definition is there in your printed notes, but because it is so very important, we'll write a definition. So give the heading compiler. Come on, do that quickly. Okay, now write the definition in your notebook. Come on, write it. Right. A compiler is itself a program which will convert our program written in high-level language, which will convert our program written in high-level language. In bracket, you write source code. I repeat, source code. Close the bracket. I repeat everything again. A compiler is itself a program which will convert our program written in high-level language to machine language. In bracket, you write object code, and close the bracket. All right. Now, in order to understand this definition, see, if you were paying attention while writing the definition, you must have already understood it. But in case you did not understand, let's try to understand it. Now, let's say you know only English and I know only French, and we want to talk to each other. Now, in this situation, what would we need in between? Come on, answer that question in your mind. We would need a translator. So that translator is this compiler. See, what happens is that when we write the program, we will write the program using statement like this. Now, this is an actual statement of C language, which is a high-level language. Okay. Now, the computer cannot understand this particular statement. I hope you remember that a computer can understand only two symbols, and that is 1 and 0. 1 and 0. Okay. So the problem is very simple. We can understand only this thing. The computer can understand only this thing. All right. And I forgot to tell you that this thing and this thing, they're equivalent. Okay. So for you, this statement is x is equal to a plus b. Okay. The same thing in computer language is this thing. They are equivalent. But the thing is that we can understand only this, and the computer can understand only a sequence of ones and zeros. So what do we need in between? So in between, we need a compiler. So a compiler is actually a program which will convert the high-level language like C, like Java, to machine language. Okay. Now, in your Viva, in your oral exam, by the way, when I'm teaching you CP, I will also prepare you for your oral exams. Okay. So please be attentive whenever I say in your Viva, because you may get these questions in your Viva, in your oral exams. I hope you have oral exams this semester. Anyway, so now in your Viva, in your oral exam, you could be asked a question that what are the two uses of the compiler, or what two activities the compiler performs? So the two main activities which the compiler performs are translation and error checking. Translation and error checking. And the order is this. Now what I mean when I say the order is this, so listen to me carefully. What happens is every language has its own syntax. Syntax means rule. Syntax means grammar. Okay. So for example, if I'm writing a C language statement, then for most of the statements, I need to put a semicolon in the end. This is the syntax of the C language. So what the compiler will do is, first of all, it will check whether your program has any errors. And if your program does not have any errors, then only it will do the work of translation. Okay. All right. Now, finally, one thing. Yesterday, towards the very end of the lecture, we had studied machine language. And I had told you that machine language has one advantage, and we'll talk about the advantage today in the second lecture. Okay. So now let me see whether you still remember the advantage of the machine language. All right. So now I have Chandni Jaisinghani in front of me. So Chandni, can you tell me what is the advantage of machine language? All right. So no reply. So I have Anjali in front of me. Anjali, can you tell me what is the advantage of machine language? All right. Again, no replies. It's okay. I think you guys have forgotten. So the advantage of machine language is that a program written in machine language is directly understood by the computer. I repeat, a program written in machine language is directly understood by the computer. See, it's very simple now. The computer can understand only machine language. So if you are writing a program in machine language, what is it which you don't need? You don't need a compiler. That's it. And that is the advantage of machine language. Anyway, now what you do is you draw this diagram, and below the diagram, you just write two uses of compiler. Number one, error checking. Number two, translation. So come on, do that. Copy the diagram and copy these two. Come on, do that quickly. Okay, so I hope you have copied this. Now let's move on. Now, after compiler, we are still doing the same heading, program or software. There are two more softwares which are important. So give the heading linker. Below that, leave a line and give the heading loader. And I hope you're sitting with 4 pens of 4 different colors. So if you have pens of different colors, use colors like these. Come on. Just give the heading linker. Just give the heading loader. The detailed definition is there in your printed notes. Just give the headings. Come on, do that. All right. Now, why I told you to use colors? Because as I told you yesterday that if you're using colors, okay, then things will become very simple for you. For example, over here, you will realize that linker is a program. Okay, linker is basically a program. It is basically a software. So linker is a program which will do some kind of linking, and loader is a program which will do some kind of loading. Now let's talk about a linker first. Now, I will not be able to explain you linker in great detail right now. So as the syllabus moves ahead, maybe after some time, you'll understand what exactly the linker does. But still, little bit idea I'll give you today. Now, what happens is, tell me one thing, how do you define a software? Okay, come on, at least this thing I'll ask some of you. So once again, I'll ask this question to Chandni, who did answer earlier. So Chandni, can you tell me how do you define a software? Again, no answer. Guess she's not even sitting. Okay. So,
Sir, a software is simply a set of programs.
very good. Okay, you can mute yourself. All right. So, how do you define a software? A software is simply a set of programs. That is one thing. Okay. Now, there is one more thing which I'll tell you. Listen to me carefully. It's pretty simple, but you should pay attention. Now, here onwards, many a times we will say, we'll use this term running a program, or we will say executing a program, running a program, executing a program, like that. So running a program means what? Running a program means that making the program do its work. Executing the program means making the program do its work. So when you run a program, when you execute a program, the program will basically show you some results. It will show you some output. Okay. Now, why am I saying all this? Because see, what happens is, listen to me carefully, that in a software, inside the software, there are many programs. So let's say there is a software in which there are 10 small programs. Now, when you execute this software, when you run this software, before you execute this software, all the 10 programs must be combined into a single program. I repeat, before you execute the software, all the 10 programs inside this software should be combined into a single program. And that work of combining, that work of linking is done by linker. Okay. So I hope you understood what a linker is. If you did not understand what a linker is, no problem. Okay, when the syllabus moves ahead, okay, we'll again come back to it and I'll explain it to you again. For time being, it does the work of linking. Now, I also hope you gave the heading loader. Okay. Now, I'm going to explain you loader in great detail, but not right now. Maybe after 1 hour. Why after 1 hour? I'll tell you. And over here, you'll have to write some notes in your own words. So what you do is you give the heading loader. Below that, you leave half a page. Okay, you leave half a page. Okay, and after you leave half a page, okay, we'll move on to the next heading. So just leave half a page. In this half a page, you are going to write. I'm sorry. You are going to write some notes in your own words. Okay. All right. Now let's move on to another important topic. Okay, so this is the loader thing, which I'll explain you later. All right, now what you do is, after leaving half a page, give the heading 1.4 Introduction to C. In bracket, you write refer PN 6,7 and also give the subheading Basic Features of C Program. So come on, quickly give these headings. Whatever you see over here, you should copy it in your notebook. Maintain your notebook very nicely. Come on, give these headings. All right, listen. Now, finally, we are going to start with our C programming. Now, till yesterday or till now, what we were doing is we were trying to understand the basic concepts of programming. And now we'll try to understand some introductory concepts of C language. For that, we are going to do our very first C language program, which is this. So whatever you see in blue color over here is a C program. Now, when you run this program, when you execute this program, it will generate some output, and that output will be this red color. Now, what you will do is first you will copy all this, and then I'll explain you in great detail. But guys, just hold down a minute. Don't start copying. Listen to me carefully. Here onwards, whenever you are copying something, okay, be very attentive while copying. That means while you are copying, okay, you should not think about something else. Pay attention while copying, because what will happen is when you're paying attention while copying, you are also revising that thing. Now, paying attention is more important in C language, because in C language, what will happen is even if you do a small mistake like this, okay, your entire program will be wrong and you will get 0 in exam. Okay, so copy attentively. I'll just tell you a few things because this is your first C program. I'll tell you a few things. Now, when you're copying all this, maintain the case of the alphabets. When I say case, I mean uppercase and lowercase. Uppercase means capital, lowercase means small. So, for example, if you see over here, most of the things are in lowercase. So if it is lowercase, you write it in lowercase. Okay. After that, you see this line displaying, and over here I wrote the second message. Now I purposely wrote it like this. Okay. So what you do is you start from here, from this P, you write till the semicolon. Then again you write till this displaying, and purposely, I repeat, purposely write the second part on the next line, the second message. Okay. Why I'm doing this, I'll tell you later on. Okay. So copy everything in blue color, black color, red color, and then I'll explain. So basically start from here, and copy till here. Okay. So I'll give you 3 minutes for this. Come on, be fast. Come on, start copying. All right, guys. So I hope you have already copied this. Okay, so now if you're not copied, just take a screenshot and maybe you can complete it later. All right, now pay attention, listen to me. When I'm explaining you, don't write anything. Now, the first thing which we'll talk in this program, the first thing about which we'll talk in this program is the comment. Now, what is a comment? A comment is a statement which is enclosed between slash star and star slash. I repeat, a comment is a statement which is enclosed between slash star and star slash. Okay. Now let me see how many of you are attentive. Answer a simple question over here. Okay. So I asked this question to Sanika. Sanika, tell me one thing. How many comments do you see in this program?
3.
Yeah, 3. Okay. So as you see over here, in this particular program, there are 3 comments. The first one is this. This is the first C program. Second is this, displaying the first message. And third is this, displaying the second message. Okay. Now, what is a comment? So a comment is a statement which describes the logic of the program. A comment in reality is not a part of the program. It simply describes the program. So what exactly I'm trying to say over here? See, now this is a very small program with hardly any logic in it. But in the real world, the programs are very big. Many a times one program has thousands of lines of code. And when I say thousands, okay, it's not an exaggeration. So what happens is that when the program is very big, it is very difficult to understand the logic of the program. So in that program, what we do is we write comments, and comments are used to explain the logic of the program to the reader of the program. I repeat, the comments are written for the reader of the program, for the person who reads the program. So for example, anybody who reads this program, we are telling him that this is the first C program. Then we are telling him that we are displaying the first message. Then we are telling him that we are displaying the second message that way. Please understand the comments are ignored by the compiler. That means the compiler will not convert the comment to machine language. I'm sorry. So just 10 minutes back, we had studied that a compiler will convert the high level language to machine language. So when you give this program to the compiler will not convert this comment to machine language. Why? Because the comment is not meant for the compiler, it is meant for the reader of the program. Now, having said all this, I have a question over here. So I'll ask you a question. So let me pick some of you. Okay, so I have, all right. Okay, so let's say I have someone called Vivek G. Okay, so Vivek G, please unmute yourself.
Yes, sir.
Okay, so my first question is that if I remove this semicolon over here, what do you think? Will the compiler report an error?
Yes.
Yes or no?
Yes, sir.
Okay, one more question. Let's say over here, instead of writing, this is the first C program. If I write, this is the 10th C program, will the compiler report an error?
No.
Yes or no?
No.
Okay, so I think you are telling me no. Anyway, so please mute yourself. So Vivek was not very clear, but I assume he gave me the right answers. See, what happens is that if I remove the semicolon over here, the compiler will report an error because we are going against the syntax of the language. But over here, if I write, this is the 10th C program, displaying the 7th message, displaying the 10th message, it's okay because the compiler is not bothered about the comments and it won't report error for the comments. In fact, there is one more thing which I'll tell you. The next thing which I'm going to tell you is simple, but please be attentive. It may confuse you, although it is simple. See, what happens is this statement is written in C language. This is written in C language. This printf is written in C language. But the comments are not written in C language. Comments are written in English language. So also pay attention to the fact that the comments are actually written in English language, not C language. Okay. Finally, one more thing. If you remember, I had told you that you purposely write these 3 words on the next line. Now, why did I tell you to do that? Because see, what happens is everything between slash star and star slash will be treated as a comment. So if I write anything over here, see where my mouse pointer is. See carefully where my mouse pointer is. If I write anything over here, then this thing is also treated as a comment. Okay. Now another thing is, one minute. Now, many a times, some college teachers, they may tell you that you can also write the comment this way. That means after this printf, you'll put 2 slashes and you will write some comment over here. You will write some comment over here. Let's say testing or something, anything like this. Okay. Now, please understand this style of commenting is allowed in C++, in Java, but not in C language. Okay. If you're doing practicals, okay, sorry, I forgot that you don't go to college now. But what happens is, if you're writing the comment in this manner, okay, you will not get an error. Why you will not get an error? That I'll explain you very soon. But still refrain from writing the comments in this manner. This is originally the syntax of C++ and not C language. Okay. All right. Now, just a minute. Let me just erase this. Okay, now after having explained you comment, now let's talk about something called preprocessor directive. Preprocessor directive. Now I will talk about this later on also for timing a little bit in short. Now any statement starting with a hash, look here, any statement starting with a hash is called preprocessor directive. So this hash include stdio.h. This entire statement is called preprocessor directive. And this thing stdio.h is the name of a file, and this file is called header file. It is called header file. Now let me talk something in general. Listen to me carefully. What I'm explaining you already know this, but still many of you don't realize this. See what happens is everything which we store in our cell phone, everything which we store in our computer, that thing is stored as a file. I repeat, everything which is stored in the cell phone, in the computer is stored as a file. Every song is a file. Every photograph is a file. Every video is a file. A song is a file with extension .mp3. A video is a file with extension .mp4. So what happens is every file will have a first name and an extension separated by a dot. For example, you may have a song, okay, you may have a song whose name could be something like abc.mp3. So this abc is the first name and mp3 is the extension. Now the first name can be anything over here, but if it is a song, the extension will be mp3. So this mp3 basically decides that what kind of content is there inside the file. Similarly, if it is a video, most probably its extension will be mp4, and the name can be anything, xyz, abc, anything. Now why I'm telling you this, because this stdio.h is actually the name of a file, and this file is called header file. So over here the first name is stdio and the extension is h separated by a dot. H stands for header. Anyway, now what you do is, if you want, you can just put an arrow and write over here that this is a header file. Come on, do that. Okay, and don't forget that this entire statement is called preprocessor directive. By the way, you'll have to keep track of this small dot over here. Okay, see currently if you see my dot is just below 1.4. Look at 1.4. Just below 1.4, you will see a small dot. Okay, so try to keep a track of that. Anyway, now once that is over, now let's go to the next part. Okay, and that next part is this main. All right. Now what happens is every C program starts with the main function. This is called the main function. All right. So what happens is some people write void main. Some people write int main. Now whether you write void, whether you write int, both are correct. Now what is the meaning of void? What is the meaning of int? That I can explain you only in chapter number 6, functions. Right now I cannot give you its explanation. Don't forget, this is just an introduction. Okay. So for time being, just understand, you can write void, you can write int, both are correct. The difference I'll tell you later on. If you write int over here, then in the end, we have to write something like, return 0 or return 1. So this return 0, return 1 will come only when we write int over here. Anyway, now whether you write int, whether you write a void, that does not make a very big difference. What you need to understand is, just a minute. What you need to understand, So what you need to understand is that this void main is the starting of the program. That means the C compiler will execute the program starting from void main. Okay. Now this is the starting point of the program. Now after writing void main, you will always put these things. Okay. Now when I say these things, why did I say these things? Okay. So let's talk something in general, not about C language. Okay. Now I'll ask one of you about one question. Okay. And this is not about C programming. Okay. So I have Sahil More in front of me. Okay. So Sahil, please unmute yourself and tell me, what is this? What do you call this?
Open bracket, closed bracket.
Pardon? What?
Open bracket, closed bracket.
And if you want to give one name to both of them, what will you call them?
No idea, sir.
All right. So I'll ask Siddharth. Okay, Siddharth. So Siddharth, what do you call them? Okay.
Yes.
Yeah, tell me, Siddharth, what do you call them?
Sir, I am Bhavin.
Okay, so Bhavin, what do you call them?
Maybe parenthesis.
Very good. Okay, listen. Now, what happens is most of the students, they call this thing as a round brackets, and many students call this thing as curly brackets. Okay. I am assuming that Bhavin has done programming earlier, so he knows the correct answer. So, aaj ke baad, from today onwards, we'll not call this the round brackets. Okay, we'll call this as parenthesis. Okay, I repeat, we'll not call it round bracket, we'll call it parenthesis. So here onwards, whenever I say parenthesis, okay, that means it is round. Okay, I don't need to use the word round for that. Now today onwards, we'll not call this curly brackets. Today onwards, what we will do is we'll call them braces. Look here. Okay, we'll call them braces. Okay. So after the main, we'll put a set of parentheses and then we'll put a set of braces, and whatever statements we want to write, we'll write inside the braces, Okay. अब एक और bracket बचा है. Okay, and that is many a times we'll use this. Sorry. So many a times we'll be using this bracket also. So today onwards, we'll not call it square brackets. We'll call it only brackets. By the way, this will be used very often in the chapter of arrays, chapter number 8, arrays. Okay. So today onward, this is bracket, this is parenthesis, and these are braces. All right. Okay. So anyway, now coming back to the logic of the program. So what you do is you always write void main or int main. Then you always put parenthesis. After parenthesis, you put a set of braces, and whatever you want to write, you write inside these braces. Now, currently inside these braces, there are two statements. I'm not counting the comments. So there are two statements. One is this printf, another is this printf. Now we'll be doing printf in great detail in chapter number 4. Which is called data input and output. For time being, I'll just explain you briefly Now this printf does the work of output. That means whatever you write inside printf will be displayed on the monitor as the output. So print over here actually means display. So the syntax over here is that you should put double quotation marks. So see, double quotes over here, double quotes over here, and whatever you want to display, you write inside the double quotes. So if you write welcome to the world of C, then in the output you will see welcome to the world of C. Now there is one more printf. Now this printf starts with /n. This /n is called new line character. I repeat, it is called new line character, and it is equivalent to the enter key of the keyboard. So if you want, you can just put an arrow over here and you can write enter key if you want. So now because of /n, what will happen is the next output will come on the next line. So begin with C programming will come on the next line. But if you see carefully, you will realize some space over here. So this space over here comes because we had given a space over here. Okay, giving the space was not compulsory, but I purposely gave it so that you understand it conceptually. All right. So now we understood the printf also. The printf does the work of displaying. All right. So this was the first C program, and we have studied the introductory concepts of this program. Now let's move on to something very important. If you don't pay attention to the next part, then you will have doubts throughout your entire semester. Almost every lecture you may keep asking me some doubts. Okay. So now what we are going to do, we are going to do all this practically. That means I will teach you how to install the C language. Okay. And then how to do programming on your computer. Okay. And we are going to do it together. Okay. All right. I'm sorry. So please be attentive. So now if you want to do C programming, you need to have C compiler. Now there are many C compilers available like Turbo C++, Code Blocks, Dave, and many more. Okay, Ubuntu and many more. Now two most popular compilers are Turbo C++ and Code Blocks. Okay. In some colleges, teachers use Turbo C++. In some, they use Code Blocks. So I will teach you installation of both of them. Turbo C++ is very old, okay, and it's in use since maybe 1990s. Okay. One more thing is that when we install the C compiler, we actually install the C++ compiler. So you can do either a C++ program or a C program. It's okay. Okay. Now, right now, don't do anything. Okay, that means don't simultaneously do things. First, listen to me. Then I'll give you 5 minutes, and in that time, you can do all these things on your laptop or your computer. Okay. If you do things with me right now, you will get confused. Okay. So what you need to do is on the internet, on Google, you can type something like Turbo C++. Okay, see over here, and just hit the enter key. Now over here, you will see this link, turboc.me. Okay, turboc.me. So you go to that website, and over here, you will see download Turbo C++, and you will see various things: Windows 7, Windows 8, Windows 8.1, Windows 10. Okay. So now what you will do is you will scroll down, and over here, see, you will see these two things: download Turbo C++ version 3.2 file and download Turbo C++ latest version file. Purposely, I repeat, purposely don't install the latest version because it is unstable. It may not work on many laptops, many computers. So we'll download this old one. Okay. So to download it, you simply need to click on this. All right. So when you click on it, the download will start. So see over here at the bottom of my screen, it's already downloaded. All right. Now, I hope you know that in your laptop, most probably whatever you have downloaded, okay, will be there inside a folder called downloads. Okay. So now let's go to the downloads folder. So this is the Chrome, and see, this is the downloads folder. All right. So now what I will do is I'll go to the downloads folder. Just a minute, guys. Just a second. All right. So now what I will do is I'll go to the downloads folder. Now in the downloads folder, you will see this Turbo C3. Okay. Now I click on show in folder. All right. And I have this zip file. Okay. Now this is a zip file which you need to extract, which you need to unzip. So right click it and just do extract here. All right. So it says confirm file replace. It is telling me file replace because I already have this with me. Okay. So I'll say yes, or I'll say yes to all. All right. In your case, it will not ask you confirm replace because you will not have another file on your computer. Okay. So now if you see over here, I have this folder, Okay. So I got this folder right now after unzipping. Okay. Now I will go inside this folder, and inside this folder, see this thing Turbo C++ 3.2 and sorry, 1 minute. And if you see its type, it's written Windows installer package, So now all you need to do is double click this. Okay. So now you double click this. All right. So when you double click this, it will, first of all, in your computer, it may ask you that do you trust this particular software? So in that case, you just click on yes. Okay. Because I have already installed it, it had asked me first time, it is not asking me now. Now, after that, all you need to do is you just need to click on next. I am not doing it right now. Because I have already installed it. Okay, so I will click on cancel. Okay, but you will simply click on next, and so on. All right. Now, once that is done, see, now I'll say, are you sure you want to cancel? So I'll click on yes. Okay. Now, once you have installed all this, what will happen is on the desktop, okay, you will have this particular icon, shortcut icon. In case you cannot see this, I will bring it over here. See, so it is written MS-DOS. In case you cannot read it, I will read it for you. So it is written MS-DOS Turbo C++. Now, what I will do is I'll double click this. Okay, 1 minute. All right, so I will double click this, and when I double click this, I will get this particular interface. Now over here, you just need to click on, Start Turbo C++, Okay. So when you click on this, you will see a blue color screen like this. Okay. Now this screen is often called text editor. I repeat, it's called text editor. Okay. Now, what we will do is we'll start doing the program over here. So I will click on file. I'll click on new. All right. Now over here, I'll start doing the program. So I'll type the same program. So very quickly, see, include stdio.h. All right. Then void main. Okay. And printf. I'll just type welcome and semicolon, and after that I can copy it this way. Okay, see, I can do Alt E and I can do C, copying, and then again Alt E and P. So one more printf. Over here I'll write /n, and then I will say begin. Okay, and I'll okay, and now I close this. Now listen to me very carefully. Now, if you are using Turbo C++, then you need to add 3 statements more. Now, why 3 more statements? I'll tell you. So first of all, over here, I'll add get ch, and don't add these statements in your notebook. Okay, let it be as it is. Then clr scr, and over here, I'll write #include, okay, conio.h. Okay, and now the program is over. Now, why I wrote these 3 statements, I'll tell you very soon. Now, once this much is done, I will now save the program. Now, all this time, what I was doing is I was doing the work of text editing. So text editing means basically typing, cutting, pasting, saving, all these things. Okay. So I will now save the program. I'll click on save. Now over here, please be attentive. Okay. Now when you save the program, by the way, if you look at this carefully, you will realize that the interface is pretty old. So as I told you, it was Turbo C++. You know, it came into picture in 1990s. Okay. So since then, the interface is same. That means when I was a student, that time also it had the same interface. Anyway, now over here you see some paths, C:, Turbo C3 bin, and then here you see this project. So what you can do is, if you want, you can just double click on this. I will double click on project. Okay. So now, just a minute. Okay. So see, now this is the path. See this carefully. C:, Turbo C3. Look at my blinking cursor. Okay. Bin project. And after that, you see something like this. Now see, I'll read it. It says no name 00.cpp. I repeat, no name 00.cpp. Now over here, what happens is, listen to me carefully, please. By default, your C program will be stored inside a file whose name will be no name 00.cpp. No name 00.cpp. Now CPP stands for C++. So if you want to create a C++ file, you write .cpp. But for time being, we'll create a C file. So here, what we will do is we'll write .c. Okay. And now, if I want a different first name, okay, then I'll erase this and I'll just click on first. Now, sorry, I'll type first. So now the name of my program, I mean this program, will be stored inside a file called first.c. Now also look at a path over here. This first.c will be stored inside a folder called project, which will be stored in bin, which will be stored in Turbo C3. Now I'll click on OK over here. OK. Now, very soon I'm going to compile and execute the program. So let me compile and execute the program. So to compile the program, I'll click on, see this, Alt, this thing, compile. On the keyboard, you can even press Alt F9. So I'll do that. All right. So it says success, press any keys. Now it is telling me success because there are no errors. Now let me purposely create one error over here. So let's say I create let's say I forget to put the semicolon. Now I'll save this and again I will compile. So now when I do that, it is telling me errors and see, it is telling me 1. Okay, and it is telling me press any key. So I'll press any key on the keyboard and now see here you will see the error. So it is telling me statement missing and this statement is highlighted. Now some of you will wonder that the error is actually in this first printf. Okay, so why is the second printf highlighted? So the point is that most of the compilers will not show you the errors precisely. Okay, they may show you the error one statement above or below. So a little bit of work you'll have to do on your own. By the way, the error which was generated over here is called syntax error. Syntax error means that there was a error in the grammar of the C language. Syntax means grammar. I'll put the semicolon again. Now, after changing the program, always save the program. Always save the program. Click on yes over here and always compile the program. Compile the program. So save and compile. So now it is telling me success, press any key. Now, once that is done, now we'll run the program. So to run the program, click on run over here. Again, click on run or press Control F9. So now, when I press Control F9, I see this black colored screen. Okay, the screen is completely black in color. So this screen, which is in front of you, okay, it is called input output screen. I repeat, it is called input output screen. This is the screen on which you will see the output of the program. Now the cursor is blinking, which means when I hit any key, the enter key on the keyboard, the output will go away. All right. So guys, this was our first C program. Now there are many more things which I need to explain you over here. But what I will do is I will give you 5 to 10 minutes. Now in these 5 to 10 minutes, what you will do is you will install Turbo C++ and you will try to do a very small program also. And why did I write that conio and clear screen? Okay, that I will tell you later on. By the way, if you want to make this screen smaller, then you can press Alt Enter. So if I press Alt Enter, see, it will become small like this. Okay. So now, come on, your time starts now. It's 6:55. Okay, try to complete this entire program by 7:05. Okay, maximum 10 minutes. So come on. And I'm still sitting in front of you over here. So if you have any doubts, you can ask me. All right. So come on, start with installation, do the program, and you can ask me doubts. You can raise your hands and I will unmute you. Come on, start. So guys, I hope you have completed the installation and you did that program. Now, just in case you could not do the installation or you could not do the program, no problem. Stop doing it right now. I will upload this lecture on YouTube, and maybe that time you can see the lecture once again and you can do all these things. Now, I'm going to teach you something more important, more difficult. So please be attentive. Now, so guys, this is, I press the Alt F9. All right. By the way, this is the full screen in front of you. If you want to minimize it, you can press Alt Enter, not Alt F9, sorry, Alt Enter. And once again, if you press Alt Enter, it will become full screen. Okay. Anyway, now I hope you remember that there are 3 extra statements which I had typed over here. That is conio.h, CLR SCR, and get CEH. Okay. And I told you, don't write these statements in your notebook. They are required only in the program. So now I'm going to explain you what happens over here. But first, let me compile and run the program. So to compile the program, I press Alt F9. Alt F9. And for executing the program, I press Control F9. So I press Control F9. All right. So when I press Control F9, I get this particular output. Okay. So everything is fine till here. Now I'll hit the Enter key. And now what I will do is I'll make this clear screen as a comment. Now, if I want to make it a comment, ideally I should type /* and //. But if you remember, I told you that even if you type 2 slashes, it is okay. Your compiler will accept it because this is actually a C++ compiler. But don't put 2 slashes in your exam, otherwise you may lose marks. Anyway, now, if this CLR SCR is a comment, that means it is now not a part of our program. So now what I do is I save the program. All right. I do Alt F9. Okay. And I do Control F9. Now over here, if you see carefully, you will realize that welcome begin is displayed a total of 2 times. Now let me execute the program a 3rd time. Okay. I will do Control F9 on my keyboard and see one more time. So guys, what is happening over here? So the concept is very simple. I have removed CLR SCR from here. So CLR SCR stands for clear screen. So if I remove CLR SCR, the screen is not cleared of the previous execution, and that's why you see the output of the previous executions. Okay. So if I do it one more time, okay, the last welcome begin which you see, the last one, okay, it is that welcome begin which is of the latest execution, the last execution. All right. And the very first welcome begin is of the very first execution. So that's how, that is the reason we should write CLR SCR so that the screen gets cleared of the previous content. Now I'll keep CLR SCR and I'll make get CH as a comment. Okay. Now what happens is, ideally, whenever you change your program, you should save the program. You should compile the program by typing Alt F9, and then you should run the program by pressing Control F9. What happens is that when you do Alt F9, you are compiling the program. So that time what will happen is the compiler will convert the source code to machine code. So don't forget, this is the source code. This is the high level language, which will be converted to machine language when you compile the program, when you do Alt F9. And when you do Control F9, that means when you run the program will finally execute and will show you the output. So ideally, every time you change the program, you should save it, you should compile it, then you should run it. But what happens is, in all the latest versions, I repeat, in all the latest versions, if you change the program and then if you directly run the program, still it will work correctly. But a good programming practice says that always save, compile, and run. Okay. So now I have saved the program, but I have removed get ch. Now see what will happen. Now I'll compile the program by doing Alt F9. It says success, press any key. Now I'll run the program and see, now I'm about to click on run. So I click. Okay, it says yes. One more time I'll click. Okay, did you see the output? No. So let's execute one more time. Did you see the output? No. So let's execute one more time. Did you see the output? No. But if you have very sharp eyes, you must have realized that there was a flicker. There was a flicker when I clicked on run. So what is happening is that when I click on run, the program is running, the program is executing, but you are able to see the output only for a fraction of a second, maybe for 1 millisecond, and then the output disappears. Now try to see the flicker this time. I'll run again, try to see the flicker this time. See, I'm sure you must have seen it this time. So basically what happened over here, that you saw the output for a fraction of a second, then the output disappeared, and that is why you could not figure it out. So if you write get ch, what get ch will do, it will hold the output on the screen. So now see, I'm running again. Now the output will be held on the screen. Only when you press the enter key, then only the output screen will disappear. So basically you should write get So basically you should write get ch if you want to hold the output on the screen. Okay. Now, what you need to understand over here is, see, I explained you why to write CLR SCR, why to write get ch. Now the question is why to write hash include conio.h. By the way, conio stands for console input output. So this hash include conio.h is the supporting statement of CLR SCR. That means if you want to write CLR SCR, then you have to write hash include conio.h. Now, what is the meaning of the supporting statement? That I will explain you in chapter number 6, functions. Similarly, the supporting statement of printf is hash include stdio.h. Okay. So if you want to write printf, you should first write hash include stdio.h. That is the logic. Okay. All right. Now I have a question for you, and you'll answer this question in your mind. And if you answer this question correctly, that means you have understood the concept of these 3 lines. Tell me one thing, that these 3 lines, conio, clear screen, get ch, are they required to be written if you are writing a program on a piece of paper? If you are writing a program on a piece of paper, are these lines required? The answer is no, because these lines are required only during execution of the program on the computer, because these 3 lines help you to see the output in a better manner. Okay, so on a piece of paper, they're irrelevant. However, if you write these 3 lines on a piece of paper, it is okay. But the problem is that if you write these lines and if you make a mistake, then you will lose marks. So better don't write these lines in your theory exam on a piece of paper. Many a times in my programs, you will see these 3 lines, and many a times you won't see these 3 lines. So that's perfectly okay. No problem at all. All right. Okay. So now I have explained you the concept behind these 3 lines. Okay. Now let's go back to our installation. So guys, now let's understand the installation of code blocks. Now, first of all, I'll go to this website www.codeblocks.org. Now, after going here, click on downloads, and then over here, click on download binary release. And here you'll get the option for operating system. So depending on the operating system, you do the clicking over here. So for example, you can download for MacBook, for Linux, or Windows. So if I have Windows, I'll go to Windows. Now these are the files. Out of these files, you are supposed to download and install one of them. So over here, you need to download this fourth one, which is called Code Blocks 20.03 min-GW. The full form of min-GW is Minimalist GNU Windows. Anyway, now I'll download it, and for download, I need to click over here. So when I click over here, it will take you to some other website where it says your download will start shortly. So see, this is the timer. And now towards the bottom of the screen, you see the download being started. Now this is a very big file, so I will just pause the download because I already have it with me. The file is already there in my computer. So I have paused the download, and now I'll go to my downloads folder where this file is already present. I hope you realize that you will not pause the download. You will allow the entire download to get completed. So now I go to my downloads folder. So over here, I'll just say show in folder, and over here you see this file code blocks 20.03 min-GW. So this is the file which you need to install on your computer. So over here, all you need to do is just double click this file, okay? So now I will double click this. So when I double click this, it will ask me, do you want to allow this app from an unknown publisher? So just say yes over here. Now, when you say yes, okay, the installation will start. When I click on next, the installation will start. Now, in my computer, it is already installed. So I will not install it once again. I will just cancel the installation. But I'm sure you understand, you will not cancel it. You will allow the installation to complete. Now, once the installation is complete, once it is over, now what you will do is you'll go to your desktop, and on your desktop, you will see this icon, shortcut icon called Code Blocks. So now I'll double click this. Code Blocks will take some time to open. All right, now this is the interface of the Code Blocks. This is the IDE of the Code Blocks. By the way, IDE stands for Integrated Development Environment. Okay, so this is called Code Blocks IDE, where you can do the C program. Now, how to do the program? So pay attention, listen to this very carefully. Now you'll go to File, you'll click on New. Now, when you click on New, on the right side, you will see this sub menu. So here, select File. Now over here, you select C, C++ source, and then click on Go over here. Now over here, you just need to click on Next. Now here it will ask you whether you want to create a C file or C++ file. So for time being, I will say C file. So Next. And now over here, you see these three dots. Okay, see these three dots over here. So click on these three dots. They will allow you to select a folder where you want to store code blocks. So now I hope you are aware of the screen where you can store programs. So see, I'll go to this PC. Okay, inside this PC, I'll go to C drive. Inside C drive, see, I have a folder called C programs. So I'll go inside C programs. Okay, and here now I'm inside C programs. That means my program is going to be stored in this folder. Now in the file name, I will select any file name. So let's say I type hello hello.c. Okay, so hello is the first name, C is the extension over here. All right. Now, once this is over, I'll click on save. I'll click on save. Okay, and here I'll click on finish. Now, when I click on finish over here, see what will happen over here. So see here, now I have a program called hello.c. Now, very quickly, I'll show you that folder of C programs. So I go to this PC. I'm so sorry. I'm sorry. So I go to C. Then I go to C programs and see here I have this hello.c, hello.c. Okay. Now when I over here you can see it has 0 bytes. It has 0 bytes. Why? Because right now the program is not yet written. Moreover, in the type also you can see this C file over here, C file. Okay. Now let me also tell you why I prefer code blocks over Turbo C++. See, there are a few differences over here. One difference is that code blocks, if you're using code blocks, then you can store your program anywhere in the computer. For example, right now, I have stored the program in a folder called C programs. But if you're using Turbo C++, you will have to store your program in that folder. That folder means C:/Turbo C3/bin/projects. Okay. So that is one problem with Turbo C++. Another thing is that code blocks will also do code completion for you and indentation. I repeat, it will do code completion for you and indentation. Look what I've typed over here. Now, what is the meaning of code completion? What is the meaning of indentation? That I will tell you very soon. Okay. So now let's start with the program. So I'll type the same program, #include stdio.h. Moreover, this code blocks is a modern compiler, modern IDE, integrated development environment. So it has many features. For example, if I want to increase or decrease the font size, I can just do pinch and zoom on my mouse trackpad. Okay, something like this. See, but these small features you will not get in Turbo C++. Anyway, now void main. All right. And now see what will happen. Now code completion will take place. See, now I'm about to type the opening brace. So I have typed only the opening brace. The closing brace will come automatically. So that is what I say code completion. Okay. Not only that, if I'm typing something like include, see, then all these things will come automatically. Let's say I'm typing int, or let's say I'm typing something like st. Let me type once again, hash. See, I gave hash. So I get all these options from where I can select this include. Okay. So this is called code completion. Anyway, so now I will just do a printf. So see, the printf came automatically, and I will just write hello code blocks. Okay. And that's it. Only this much I'll do in the program. Now, just a minute back, I had written a word called indentation. So indentation means what? Indentation means pushing on the right side so that things look better. So see, if you see carefully, this printf is pushed a little on the right side. And this I did not do, this code blocks did automatically. So these are some small features because of which I prefer code blocks instead of Turbo C++. Anyway, now once this is over, I will compile and run the program. So for compiling, I go inside, I will first save the program. So I save the program. Now I go to build. Now for compiling the program, either I can click on build or I can click on compile the current file, anyone. I'll prefer build. Now when I click on build, you will see one error over here, error. Okay, now let's see what error. So, okay, now there are two errors. This error says, see, first this error, unfortunately, I cannot increase the size of this thing. So in case you cannot read it, I'll read it for you. It says, error printf was not declared in this scope. So see, this is line number 4. And in line number 4, if you see carefully, instead of typing printf, I have typed printf. That means I missed the T. So I put the T now. Okay. So this error is gone. Now there's one more error which says error main must return int. So what happens is that when we are using code blocks, that time we cannot write int void main, we must write int main. Now, why int main, why not void main, all these things I will tell you in chapter number 6, functions. Right now, it's not very important. And if you want, in the end, you can write return 0 or return 1. But in code blocks, writing this return 0, return 1 is optional. So once again, I'm telling you, this int over here, this void over here, this return 0, return 1, all this will not affect the logic of your program. Okay, the logic of the program will remain same. So no matter which compiler you are using, it's okay, whatever you write, int, void, it's okay. Okay. Anyway, now I have removed the error, so I'll save it again. I will build it again. And now I'll run the program. So for running the program, click on build again. Now click on run. Now either you can first click on build and then click on run separately, or what you can do is you can click on build and run. So compiling and executing will take place one after another in one command. Anyway, right now I'll click on run. So when I click on run, this is the input output screen which says hello code blocks, hello code blocks. And after that, same thing, process, return 0, all these things. Okay. Now I hit the enter key. So you saw the output of this program. All right. So guys, this is how code blocks works. Now, having done the practicals, having installed Turbo C++ and code blocks, now let's understand some more concepts. So I want everybody to give this heading. Come on. So give this heading, stages or softwares involved in program development. Give the heading in your notebook. All right. Now what we are going to discuss is slightly difficult. So please be very attentive. Now what happens is whenever you are doing a C program on your computer, several softwares, several other programs act on your C program. That means during the development of your C program, you need help of at least 5 different softwares, 5 different programs. So under this particular heading, we are going to study which 5 softwares are required for the development of your C program. In other words, we are going to study the 5 stages of the software development over here. Okay. Now, the first stage is called text editing. And for text editing, you need text editor. Now, what is the meaning of text editing? So text editing means typing, cutting, pasting, saving, all that. Now, if you want to do text editing, you need a text editor. The simplest example of text editor is the Notepad. So Notepad, Microsoft Word, all of them are text editors. So that way what happens is that whenever we do C program, first we need to type the program, and for that we need a text editor. So this blue screen which you saw just now, this blue screen which you have been seeing in this lecture, this is basically a text editor. Similarly, when we were doing code blocks, okay, you had that white color screen. So that is also the text editor where you type your program. So once the text editing is over, the next thing which you will do will be compiling. So in Turbo C++, you can press Alt F9, okay, and in code blocks, you can select the option for build. So whether you do build or whether you do Alt F9, you are basically compiling your program. Now, when you are compiling the program, again, two softwares act on your program. Two softwares, okay. The first one is called preprocessor, and the second one is called compiler. Now you know what is a compiler, so let's talk about the preprocessor. It is slightly difficult, so please be attentive. First of all, over here the word pre means before. So we call it preprocessor because this software acts before the compiler. It will do its work before the compiler. So that is why it is called preprocessor. Now what work it does, so let's understand that. Now for that, have a look at this Turbo C++ program, okay. Now I hope you remember that in this particular program, there is a statement which is called Preprocessor Directive. So tell me, which is that statement? It is the very first statement, or I will say the first two statements, which are called hash include stdio.h and hash include conio.h. So these statements are called preprocessor directives. In fact, any statement starting with a hash is called a preprocessor directive. Now, things which I'm going to explain you are difficult. Listen to me carefully. And this could be asked in your oral exam or even in your theory exam as a 2-mark question. So listen. Now, if somebody is asking you that what work preprocessor does, so in one word you can say that preprocessor does the work of substitution. I repeat, preprocessor does the work of substitution. Now the question is, what substitution? So for that, let's go to the installation folder of Turbo C. So this is my PC. This is my PC. So here I go to Windows. Here I go to Windows C. Okay. Now see, there is a folder called, just a minute. All right. So see, there is a folder called Turbo C3. I go inside this. Now inside this, see, there is a folder called include. Look at the name include. Okay. Now inside this, look at all these files. Look at all these files carefully and look at the type over here, H file. Now all these files which you see over here, they are called header files. Okay. And their extension is .h. I repeat, they are called header files. Now one such header file is this stdio, which you already know. Now I'll just double click and open this header file. So you can see that inside this header file, there are so many contents. See this? Now we are not bothered about its contents, but just pay attention to the fact that there are 237 lines in it. See it, look towards the bottom of my screen, right bottom, see this 237. Okay. So you just need to pay attention to the fact that there is a header file called stdio.h, which has some 237 lines of code. Okay. All right. Now you understood this. Now what next? So listen, now let's go to our program. So I'll close all this. Okay. So now can you answer in one word? Can you answer in one word what work the preprocessor does? The answer is substitution. Now what happens is, listen to me carefully, when you press compile over here, okay, when you press Alt F9 over here, the preprocessor will first come into action and it will do the work of substitution. Now the question is, what substitution? So listen to me carefully. What the preprocessor will do, it will replace this line, the very first line. Okay, look carefully. It will replace the very first line by the contents of stdio.h. So I hope you remember that you had seen 237 lines inside this file stdio.h. So those 237 lines will be substituted over here. Okay. Now you may have a question in your mind that why this substitution is done. So unfortunately that I cannot explain you right now. That I will explain you in chapter number. Take a guess which chapter number? Chapter number 6, functions. Okay. Anyway, so all these concepts are related to functions, so that we'll see later on. So you understood the preprocessor now. Now after preprocessor, the compiler will come into action and the compiler will perform two activities, error checking and translation. So first it will check whether there are any errors in the program, and if there are no errors, then it will do translation of high-level language to machine language. Okay. Now, once the translation is done, now what you will do is you will, once the compilation is done, let me do the compilation and show you. So see, I click on compile. Now, when you see this success, press any key. It means that two softwares have finished their work on your program, and these two softwares are preprocessor and compiler. The compiler has also converted your source code to machine code. Don't forget this thing is called source code. Now, once all that is done, now I'll click on run, or I'll on the keyboard, I'll press Control F9. Now, when I press Control F9, again, two softwares will work on your program, and these two softwares are linker and loader. Linker and loader. Now, what work linker will do? What work linker will do? So listen to me carefully. I've explained this to you, but once again, I'm telling you. I hope you remember the definition of a software. So a software is simply a set of programs. A software is simply a set of programs. So what happens is, whenever you are about to execute a software, that time, just before the execution, all the individual programs of the software must be combined into a single program, and only after that the execution can start. So combining all these programs into a single program is called linking, and that work is done by linker. Now our program, this program is a very small program in which the linker has hardly any role to play. Okay, so you understood what the linker is. Now after linker, the next software which will work on your program is the loader. Now I need to explain you loader in great detail. Okay, I hope you remember, you have even left half a page for that. Okay, so that I will explain you, but for time being, just understand that your C program goes through 5 stages: text editing, pre-processing, compiling, linking, and loading. Okay, loading is sometimes also called executing. Now I'll explain you loader, but before that, what I suggest is you just quickly copy all this. And after copying all this, you will go to that page where you are given the heading of loader and you have left half a page. So there I will explain you something, and then you will make a note of it in your own words. But first, quickly copy all this. Come on, start. Okay, now let's go to loader. Okay, so this will be the last thing which we'll study over here. Okay, it is difficult, but it is very interesting, so pay attention. Now we need to go back to loader. So I hope you have given this heading. So go back to this page where you had given this heading, and I think you have left half a page below this. All right, now the explanation is difficult but very interesting, and after the explanation is over, I would want you to write some notes in your own words, so please be attentive. Okay, now what is a loader? So the loader is also a program, it is also a software which will do the work of loading. Now what loading? So listen to me very carefully. Now I hope you remember that this is the block diagram of the computer. This is the block diagram of the computer. Now I'm so sorry. Now in this block diagram, there is this memory unit and this CPU. This arrow shows the transfer of data from the memory unit to CPU, and this arrow shows the transfer of data from the CPU to the memory unit. Now right now we are not interested in this arrow, so let it go. Okay, 1 minute, just a minute guys. So just a minute. Okay, before that I'll tell you something else. There is some, I just spoke about something and the order of animation is something else. So I'll once again tell you. So this is memory unit, and this entire thing is the block diagram. This entire thing is the block diagram of the computer. This is memory unit and this is CPU. So you saw this block diagram yesterday. Okay. Now I hope you also remember that yesterday I had taught you that this memory unit can be of 3 types: ROM, hard disk, and RAM. ROM, hard disk, and RAM. Now on ROM, you cannot do any writing, you cannot do any storing. So let's leave it out of question. Okay, let's not talk about ROM because we cannot touch it. Now let's talk about RAM. Okay, this memory unit could be RAM, or this memory unit could be hard disk. Okay. All right. Okay. Now, before I proceed further, I have a very simple question for you. Very simple question for you all. And I want one of you to answer this question. This question is not about C language. Okay. It's not about C language. Okay. So, the question which I'm asking you, it is about a cell phone. It is about a computer. Okay. The same question applies to both the cell phone as well as computer. All right. So I'll ask this question to, let's say, Kyle Crasto, if I'm pronouncing your name correctly, Kyle. So Kyle, can you hear me?
Hello. Yes.
So I have a question. The question is that when you're storing a song in your cell phone or in your computer, you will store the song on the hard disk or on the RAM.
Hard disk.
Very good. Okay. Now please mute yourself. Now you must have heard that he said that we'll store the song on the hard disk. Okay. So here also in my example, let me store the song. Let me store the song on the hard disk. So look here. So I have my hard disk, and on the hard disk there is a song. Okay. Now let's say I double click on that song. Okay, I double click on the song, and when I double click on the song, obviously the song will start playing. Now here onwards, you guys should think like engineers, like programmers. That means you should wonder in your mind that when I double click on the song, what really happens in the background. So I hope you remember that everything which is stored in computer memory, I repeat, everything which is stored in computer memory is stored as a sequence of ones and zeros. So this song which you see over here, this song is also stored as a sequence of ones and zeros. No matter what you store in computer memory, it is basically ones and zeros. So this song is basically some sequence of ones and zeros. Now what will happen is that when you double click on that song, these ones and zeros will start flowing from hard disk to CPU. By the way, I'll just remove this arrow, it is not required, so let it go. Now, what will happen is these ones and zeros, they will start flowing from the hard disk to CPU. So see, all these ones and zeros of the song, they go to the CPU. Now, in CPU, this P stands for processing. Okay. So what the CPU will do is the CPU will convert ones and zeros. The CPU will convert ones and zeros to, can you take a guess to what? It will convert all the ones and zeros to sound, Okay. So in hard disk, this 1 and 0 was there. It went to CPU. The CPU converted ones and zeros to sound, and then this sound gets outputted on the speaker. I'm sorry. So I hope you must have understood this entire mechanism. Okay. Now what happens is, listen to me carefully. If the song is directly transferred from hard disk to CPU, then you will hear the song with breaks in it. Now, when I say breaks in it, what I mean is, see, if you're talking to your friend on phone, and if the signal is not very clear, what will you tell your friend? So you will tell your friend that your voice is breaking. So that breaking effect you will hear over here. Okay. So now I'm going to ask a question to one of you, and in my physical classes, what used to happen is the one who answered the next question correctly, I used to give him or her a chocolate. Okay. So unfortunately, you know that I cannot do over here, but you may still assume that you got the chocolate. So now this is my question. So everybody listen to my question. The question is, if this is the mechanism, why will you hear the song with breaks in it? Why will you hear the song with breaks in it? Okay. So anybody who knows the answer, who thinks that he knows or she knows the answer, can unmute and answer the question. It's okay to give a wrong answer. It's better to give a wrong answer instead of keeping quiet. You may unmute yourself and you can give me the answer. Anyone? Okay, so here is the answer. Listen, I hope you remember that yesterday we had studied the differences between hard disk and RAM. Now I want you to turn your pages, 1 or 2 pages backwards, and tell me the second difference between hard disk and RAM. Come on, you can unmute yourself and you can tell me the second difference. What is it?
Hello.
Yeah, what is the second difference?
Low access time and high access time.
Very good. Okay. So now this has something to do with it. So listen to me carefully. So the concept over here is that hard disk has high access time, which means hard disk is slower than RAM. So what will happen is that if the song is directly transferred from hard disk to CPU, then this song will be transferred very slowly. I repeat, this song will be transferred very slowly, and the CPU will not receive the required number of bits continuously. So what will happen is the CPU is very fast. The CPU is very fast. So it will convert some amount of bits to sound, and then it will wait for the hard disk. Okay. So while it is waiting for the hard disk, you will hear that breaks. Okay. I repeat once again, the CPU is fast, okay, but the hard disk is not very fast. So what will happen is the CPU will quickly convert the received bits, the received 1 and 0s to sound, and then it will wait for more 1s and 0s from the hard disk. But hard disk is very slow, and that is why while the remaining bits are being transferred, you will hear that break in the sound. Okay. Okay. So now what happens is, in reality, do you ever hear breaks in the song when you are listening the song? Come on, anybody answer the question.
No.
No, you don't. You never hear the breaks. Okay. Now, why you never hear the breaks? Because in reality, things don't work this way. Okay. What I told you just now, okay, this is actually wrong. It could have happened that way, but it does not happen this way. In reality, between hard disk and CPU, comes RAM, the main memory. What happens is, listen to me carefully, things are interesting. When you double click on the song, the entire song, I repeat, the entire song is first copied from hard disk to RAM, and then while the song is being played, I repeat the word while is important. While the song is being played, the song is transferred from RAM to CPU. So the bits 1s and 0s are stored in RAM, and while the song is being played, it is transferred from RAM to CPU. Okay. The RAM is very fast, so that problem of breaking will not occur now. Now, some of you must have forgotten that we are discussing over here a software called loader. Okay, we want to understand a loader. Okay, so now the question is, what is this loader? Okay, so I want one of you to take a guess over here. So Rahul Kapadia, can you tell me what a loader will do over here? Okay, anyone else can unmute, and can you tell me what role the loader will play over here? Very simple, very simple. I always tell my students, pay attention to the name and derive the meaning from the name itself. Loader will do the work of loading. So look here. Loader will load the song from the hard disk to RAM. Look here. So the work of loading the song from hard disk to RAM is done by loader. Now the discussion is not over. Something very important about the loader is going to come. But this entire discussion was a little difficult. So what I suggest is you just draw this part of the diagram. And write some notes about it in your own words. So I'll wait a minute, 1 minute, 2 minutes. Just copy this center part. Okay. You don't need to draw CU and ALU. Just draw the CPU. Just draw this arrow. Just draw the speaker. Okay. And just write some notes in your own words. Come on, do that. All right, now let's continue. As I told you, the discussion is not over. If you're not finished writing, no problem. Write later on. Just listen to me very, very, very carefully. The next 2 minutes are very important, slightly difficult. Listen to me carefully, okay? Now here I took example of a song. Here I took example of a song. But what I told you over here is applicable to each and every program, each and every software which is installed on your computer, which is installed on your cell phone, okay? Now, in order to explain you this thing, I will take example of WhatsApp, okay? Now, answer a simple question. Are you using WhatsApp right now? Come on, anybody, unmute and tell me, are you using the WhatsApp right now? I don't think so. Okay, right now I don't think you are using WhatsApp. Okay, so what happens is, listen, WhatsApp is installed in your cell phone. By the way, whatever I tell you about cell phone is applicable to computer also. I told about it yesterday. So coming to WhatsApp, right now you are not using WhatsApp, but WhatsApp is installed on your phone. So right now WhatsApp is present in the hard disk of your cell phone. Okay. In fact, it is always installed in the hard disk of the cell phone. All right. Now, let's say after the lecture is over, you click on the WhatsApp icon. Now, when you click on the WhatsApp icon, basically you are trying to run WhatsApp. You are trying to execute WhatsApp. Okay. Now, when you click on the WhatsApp icon, okay, what will happen is the loader will transfer the entire copy of WhatsApp from hard disk to RAM. So at this moment, there are 2 copies of WhatsApp in your cell phone, one in hard disk and one in RAM. Okay, don't forget the RAM is also there in your cell phone. Now, while you are using WhatsApp, I repeat, while, okay, let's say you are typing a message to somebody, that lecture is over, okay, something like that, okay. So while you are using WhatsApp, the CPU will use that copy of WhatsApp which is in RAM. Okay, so that copy of WhatsApp which is in RAM, that will interact with the CPU. It will interact with the CPU. Now, let's say you have finished using WhatsApp, and let's say now you close WhatsApp. Okay, you close WhatsApp, you remove it from the memory of the phone. Okay, so now when you close WhatsApp, what will happen is this copy which was there in RAM, okay, it will get automatically deleted, and now only this original copy will be there in your cell phone. Now, whatever I told you just now, it is applicable for everything. And when I said everything, take that word everything very, 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 very seriously. For example, we had this Turbo C3, okay, we had bin, okay, we had project, and inside this there was this file first.c. Now, my simple question to you is, see, look at this path, C drive, Turbo C3, bin, project. Now, my question to you is, and I want anybody to unmute and answer my question, unmute yourself and answer the question. This file, first.c is right now stored inside hard disk or RAM. Anyone can answer this question?
Hard disk.
Very good. Right now, it is stored inside hard disk. See, a very simple thing, this C drive, okay? This C drive, this thing, this is the hard disk, okay? If you want, look here. This is my PC, and this is this hard disk. This C, this D, they are all hard disks, okay? So, basically, the point I'm trying to make is that program, this program, let me again go to the program. All right. So this program, all right, first.c is actually stored in a hard disk in the beginning. Now, when I execute this program, what happens is this program is loaded from hard disk to RAM, and the work of loading from hard disk to RAM is done by the loader. So if you ask me what is a loader, okay, the loader is a program which will load your program from hard disk to RAM, and it will finally start the execution of the program. So loader is that last software which acts on your program, and it starts the execution of this program. All right, I mean, it starts the execution of your program. So please understand one thing, whatever I explained to you about that song It is applicable to all softwares, all programs, everything, all apps on your cell phone. Okay. There's one more interesting thing. Listen to this very carefully. It's very interesting. Okay, what I'm going to ask you. See over here in your computer, when you click on this PC or my PC, okay, you see something like this: Windows C, Data D, something like this. Okay. Now tell me one thing. Please understand my question. Many of you will not understand my question. Now over here, you see this hard disk. This is the hard disk. This is the hard disk. Okay. But have you ever seen RAM on your laptop, on your computer? I mean, the way you see icon for this, okay, I can go inside this and I can store things over here. So that way, do you see any option for storing anything in RAM? Again, unmute yourself and give the answer. Anybody?
No.
No.
Yes or no?
No.
No.
No. Okay. You will never ever see anything which gives you the option to store anything in RAM, because you cannot store things in RAM. Only loader can store things in RAM. Okay. So this was the whole concept of loader and RAM. Okay. Finally, in your oral exam or in your theory exam, you may have this question. Okay. So I want everybody to copy this question. Come on, everybody copy this question. All right, just start with the answer. Just everybody come on, start writing the answer. Right. The following are the stages of program development. The following are the stages of program development in order. Okay, so the question is very simple. Over here, there are 5 stages of program development. We need to write these 5 stages in order. Okay, so please unmute yourself and tell me the first stage, only the first stage. What will be the first stage? Anybody can answer?
Editing.
Yes, very good, very good. The first stage will be editing. Okay, next stage.
Preprocessing.
Very good.
Pre-processing.
Very good, very good. All of you, very good. Pre-processing. Okay. Next stage.
Compiling.
Others, come on.
Compiling.
Very good. Compiling. All right. Next stage.
Thinking.
Linking. Very good. And the last stage.
Executing.
Yes. And executing is nothing but loading. So now you'll copy all this, and this executing, here what you do in parenthesis, just write loading also. Okay. So copy the red color and just write loading in parenthesis. All right, guys. So this was the end of today's lecture. Now, as I told you, I'll upload that installation video and all on the YouTube. As soon as I install the video, I'll inform you on our WhatsApp group, and whatever WhatsApp group you are. Okay. Also, this was the end of your trial classes, the demo classes. So if you wish to take admission, you can contact me. The fees for this course will be 5,500, in which I'll teach you C as well as C++. Okay. So now, if you have any doubts, you can ask me those doubts. Otherwise, you can leave this meeting. Okay. Thank you very much. So any doubts?